So this is a day 3 of 108 day Verilog course. So wait a minute. So in this session we will the topics covered are identifiers and keywords, data types, nets, registers, and vectors. So let's start our session with identifiers and keywords. Wait a minute. Let me take the pointer. Yeah. So keywords are specialized identifiers reserved to define the language constructs. Keywords are in lowercase. So basically these keywords are reserved characters. Like example in C we have int like that. So here we have input, output, and we have some keywords. So these are reserved identifiers. These are known as keywords. So basically these are reserved and they are mentioned in smaller case, lower case. So keywords are special identifiers reserved to define the language constructs. Keywords are in lower case. And coming to identifiers, identifiers are the names given to the objects so that they can be referenced in the design. For example, let us again consider our half adder example. So in our half adder example, if we have the input A and input B, or let's say we have two inputs and two outputs, then we should give some name to the inputs and outputs, right? So we are just giving name for one input as A, and the name for other input as B, and the name for one output is sum and other output as C out. So the names which we have given to these inputs and outputs are called as identifiers. So basically these are the names given to the objects so that they can be referenced in the design. So identifiers are made up of alphanumeric characters and underscores and dollar sign and are case sensitive. So here these identifiers can be alphanumeric, meaning like we can give identifiers as a underscore 1 2 3. We can use the alphabet as well as number, and these are case sensitive. For example, if we declare any input as, for suppose, a b c, in Verilog if we declare any input, for example if we declare an input as small a b c, this is our input, and if we use this input in our design as, for say example, capital A B C, then the simulator will throw the error since this is case sensitive. So we should keep in mind that these identifiers are case sensitive. We should use them carefully. So yeah, identifiers are the names given to the objects so that they can be referenced in the design, and the identifiers are made up of alphanumeric characters and the underscore and the dollar sign and are case sensitive. So these are the identifiers, and identifiers start with an alphabetic character or an underscore, and they cannot start with a number or a dollar sign. So here the identifiers can start with a letter, smaller or uppercase or smaller case, as well as they can start with an underscore. They can start with an underscore. So identifiers can start with a smaller letter or a capital or an underscore, but it cannot start with a numeric number. It cannot start with a number. So identifiers, we should be careful while declaring an identifier. It should start with an alphabetic or an underscore. It cannot start with a number, and it cannot start with a dollar sign. If an identifier is starting with a dollar sign, then it is not valid. We will discuss in our upcoming videos this the identifiers which are starting with dollar sign or keywords. These are special type of keywords. These are like we have dollar display and dollar monitor. So these are system functions. So we cannot declare identifiers which start with dollar and numbers. So this is about the identifiers and keywords. Is this clear for everyone? So these are the identifiers and keywords in Verilog. Now coming to data types in Verilog. So Verilog supports 4 values and 8 strings to model the functionality of real hardware. So in Verilog we have 0, 1, unknown and high impedance states. So these are the 4 states which are supported by the Verilog. 0 can stand for logic 0, or it can stand for representing false. So we will see in the upcoming lectures, like when we are using boolean, we use 0 for false and 1 for true. So here 0 can represent logic 0, or it can use as a false to representing false, and 1 is used for logic 1, or it can be used to represent true state. And X we already know it is unknown, and Z is for high impedance. So these are the 4 value sets in Verilog. So is this clear for everyone? Coming to nets. So nets are basically used for representing the connection between the hardware elements. So just as in real circuits, nets have values continuously driven on them by the outputs of device that they are connected to. For example, we will take an OR gate. Here we have an input A, B and output. So here the output changes continuously. The output, remember this term, continuously. So the output changes continuously whenever there is a change in the inputs A and B. So whenever there is a change in inputs A and B, there is an change in the output continuously. So whenever there is an change occur in the inputs A or B, then the output will change continuously. So basically this behavior is replicated by the nets in the Verilog. So basically this, in this nets, these the value in the nets is changed continuously. So basically these nets are used in the cases where the value will get changed continuously. And for example, and another example where we use nets is, for example, if we have 2 modules, this is module 1 and module 2. This is one design block and this is another design block, and if we want to connect these 2 design blocks, then we will use this net. Basically these are used for connecting 2 design blocks. So for connecting these 2 design blocks we use nets. So the value in this nets will change continuously. So just as in the real circuits, nets have values continuously driven on them by the outputs of the device that they are connected to. So these are the nets in Verilog. So nets are declared primarily with the keyword wire. So if we want to declare any net, we will use the keyword wire followed by the identifier name. For example, A. A is the identifier, that is the name, and wire is the data type, that is net data type. Basically we have 2 data types. One is net data type and other is reg data type. So here for representing a net data type, we will use the keyword wire followed by an identifier. So A will become a net. So the value in A will be changing continuously. The value in A will change continuously. So this is an important point which we should remember in interview. They will ask what is mean by net data type, and what will be the value, how will be the value changing. So in the net data type, the if an identifier or a variable is declared as a net data type, then the value will be changing continuously. So a net data type is declared by a keyword wire, and nets are 1-bit values by default unless they are declared explicitly as vectors. This is also a very important point which can be asked in interviews. So nets are 1-bit data type. So the size of the net is 1 bit. Here the size of the net is 1 bit unless they are declared as vectors. We will discuss about these vectors in upcoming slides. So for now, if the net is not declared as a vector, that is, if it is declared simply as wire B, then what is the size of B? It is equal to 1 bit. Since it is not declared as vector, so the size of B is 1 bit. If it is not declared as vector, then the default size of the net is 1 bit. And coming to default value of net, which is nothing but high impedance. The default size of net is 1 bit and the default size of net is high impedance. And the term wire and the net are often used interchangeably, like we can call them as net or wire, there is no problem. And the default value of a net is high impedance. So for declaring a net, we will use the keyword wire followed by the identifier name. So if we declare wire A, then A will be driving continuously. The value of the A will be changing continuously. It cannot store any value. A cannot store any value. This is also a point to be remember. It cannot store any value. It just simply go on driving the value. It just simply go on changing the value. So this is all about the nets concept. So is there any doubt in the concept of net? Can we move forward? So this is all about the net data type. Here we can see the example. Here A is declared as a net data type since it is a wire keyword is used. So A is a net data type. So declare net for the above circuit. So A is a net data type, and wire B comma C. B comma C are two wires, and wire D is equal to 0. Net D is fixed to logic value 0 at declaration. We can, so basically, let's say we have 3 variables A, B, C. We can declare the variable wire A, and we can assign a value to A like this. So for assigning the value to a net data type, we use a keyword called assign. This we will discuss in upcoming sessions. So if we want to assign any value to the net data type, we will use the keyword assign and we will assign the value. Simply we cannot write A is equal to 0. This is not valid because it is declared as wire. So if we use a wire, then we should use the keyword assign A is equal to 0. Simply we cannot assign A is equal to 0. This is not valid. And we can also declare another net data type called B, wire B, and we can assign B is equal to 0. This is also valid. And we can also write wire C is equal to 0. We can at a time declare a wire a net data type and we can assign the value at the same time. This is also a valid way. So like this we can assign the values to the net data types. Now coming to registers. So registers represent data storage elements. So basically nets cannot store any value. nets cannot store any value, but registers can store the values. So registers are used to store the values. So registers retain value until another value is placed onto them. For example, if we declare any variable as reg, so if we declare any variable as register as reg a, then we can assign that variable to any value. A is equal to 0. This is a valid, and until we assign another value to this variable, say after 10 time units, we will discuss about this, what is this hash 10 in our upcoming videos. So for now, let's say a is equal to 0, and let's say this means after 10 time units, if we assign a is equal to 1, then up to 10 time units a will store the value of 0. So a is equal to 0 up to 10 time units, and after 10 time units we are assigning 1, so a will have the value of 1. So up to 10 time units a will store the value of 0, and after 10 time units a will store the value of 1. Whereas in case of nets, that is wire cannot store the value. It will go on continuously changing the value. And in Verilog, the term registers merely means a variable that can hold a value. In Verilog, registers means a key. Registers are nothing but which holds the value. It is not the registers which are used in digital circuits. Don't get confused with that. This is also a valid interview point, that they will ask that is Verilog registers are same as the registers in digital electronics. So not that type. So these registers are different from the one which are in the digital electronics. So these registers are basically used for storing the value. And registered data types are commonly declared with a type reg. So for declaring a variable as register, we will use the keyword reg. So if we use the keyword reg, then a variable is declared as register, and the default, coming to default value and size, default value is unknown and default size is 1 bit. So this is also a very valid interview question. They will ask what is the default value of a register and default size of register. So you can answer them. The default value is unknown and the default size is 1 bit. For example, here we can see they have declared a reg reset. So reset is a identifier, and reg is a keyword. So reset is a registered data type. This is a keyword. So if we want to declare a reset which holds a value, here declare a variable reset that can holds its value initial. This construct will be, so we will sorry, here some printing mistake, I will write here. So here reg reset, if we declare an identifier as a reg, then reset will be of registered data type. So reset can hold the values. So reset, if we declare any identifier as registered data type, then it can hold the values. And here inside an initial beginning block, we will discuss about this initial beginning block in our upcoming videos. So within an initial beginning block, if we want to assign reset is equal to 0, then reset will hold the value of 0 until it is driven by another value. For suppose after 10 time units, we will discuss about this timing in next videos. So after 10 time units, reset will be equal to 1. So for 10 time units, reset will hold the value of 0, and after 1 is assigned to it, then the value is changed by 1 in the reset. So like this, registers are used for storing the value. So is this clear for everyone? Now coming to vectors. So please concentrate in this topic, like we get more confusion in this vectors. So let me take an example here. So for example, if we have 8 tick, not 8 tick, 4 tick binary 0 0 0 1, what this physically means, this means 4 bits, 1 2 3 4, 0 0 0 1. So here we have 4 bits. The value is 0 0 0 1. So if we want to store this 4 tick binary 0001 into a registered data type or a net data type, how can we store it in the registered data type or net data type? We will use vectors for storing the these values more than 1 bit. If something, the value is greater than 1 bit, then we will use vectors for storing the value. Here we have 0 0 0 1. We cannot simply store, we cannot simply declare reg a, and we cannot store a is equal to 4 tick binary 0 0 0 1. This will not, it can store, but it will store only this 1 bit. It will store LSB, but it will not store the entire value. So for storing the entire value, we will use the vectors. So for creating a vectors, we have the syntax. For example, we have to store a 4-bit value. Let's say we have 4 tick binary 0 0 0 1. So we will declare a register. First I will take the scenario where we want to store this value in a register. So I will declare register followed by the size. So what should be the size? 1 2 3 4. So it should be 4. So for declaring the size, I will write 3 down to 0. So 0, that is LSB, this is 0, followed by 1 first bit, second bit, and third bit. This is 3 down to 0. This is one way of representing the size. This column represents down to, or we can write reg 0 to 3. Now here 3 represents MSB. In this case, we can see the third bit is the MSB. If we write reg 0 to 3, then this bit will become MSB and this bit will become LSB. So I will take another example. If we have 4 tick binary 1101, so this is third bit, this is second bit, and this is first bit. This is 0 0 0th position 1 2 3. So if we write, so we have 1 2 3 4. So the size should be 3 down to 0. That means third bit, second bit, first bit, 0th bit. Or if we represent 0 to 3, then this will be MSB and this will be LSB. I will take another example for better understanding. If we have 0 0 0 1, then if we represent 3 down to 0, then this will be MSB. And if we take 0 to 3, then this will be our MSB. That is, it will be 1000. That is, if it is stored in a register, it will store like this. Because we have taken 0 to 3, so it will take this one as our LSB, and it will store accordingly. 1000, it will store like this. So be careful while representing these vectors. So that's why I was emphasizing more on this topic. So we should be careful which should be our MSB and which should be our LSB. Is it clear? So, like this, we should be careful while declaring the size and the upper value and lower value. So now, let me now format. Okay, it's got deleted. Okay, no problem. So like this, vectors can be declared at high to low or low to high, but the left number in the squared brackets is always the MSB of that vector. And here, if we want to, for example, here they have taken reg 7 down to 0 bus. So bus is a bus is an identifier of type reg. This is an data type, and the size of this bus is 8-bit. And the size of the bus is 8-bit. For physically representing it, here we have 1, 2, 3, 4, 5, 6, 7. So 7, 6, 5, 4, 3, 2, 1, 0. So this is bus. So this bus can store 8 bits. So this is the meaning of this statement. Reg 7 down to 0 bus means this bus variable can store 8 bits. And what is a MSB? Here 7 is a MSB and LSB is 0. Or if we or if we have written reg 0 to 7 bus, then it is same. It can now store 8 bits, 1, 2, 3, 4, 5, 6, 7. But here the MSB will be 0 followed by 1, 2, 3, 4, 5, 6, 7. So we should be careful while declaring the size. Basically, we will prefer this notation only. In some scenarios, we will prefer this notation, this type of notation. So this is another valid point. And if we can also use wires for representing vectors. For example, if we have wire 5 down to 0 A, then A is of type wire, is of type net data type, which can store 6 bits. That is 1, 2, 3, 4, 5. Not store. So wire cannot store, right? So it can continuously drive 6 bits. 5, 4, 3, 2, 1, 0. That is wire A can continuously drive up to 6 bits at a time. So this is how we should use vectors in Verilog. So is this clear for everyone? Or any doubts? Okay, thank you. Yeah. For example, if we declare a vector of 3 down to 0 A, and if we store A is equal to, it is a reg, so I am directly storing it. But generally speaking, if we declare any reg 3 down to 0, then we cannot simply declare it. We should use initial beginning block. I will discuss about this in upcoming videos. So we cannot simply directly store anything into reg. We should use either initial beginning or process block. For reg, process begin, sorry, not process, always. Process is used in VHDL, always is used in Verilog. So within an always begin and block, we will assign the value of reg. only the value of reg can be assigned in only these two blocks. Without in these two blocks, out of these two blocks, we cannot assign the value of reg. Whereas for the case of wire, we will use assign for assigning the value of wire. So yeah, we will discuss about this initial begin process, sorry, always begin in and assign in our upcoming videos. So now if I want to assign the value of a is equal to say for suppose 4 tick binary 0001, I'm assigning the value of a which is equal to 0001. And if I want to extract the MSB, then how can I extract? That is, I will declare another register called B. This B can hold only one value. So within another initial beginning block, I will assign B is equal to, I want to extract the MSB. So B is equal to, what is MSB? Here we can see we have written 3 down to 0. So 3 is our MSB. So I will write A of 3. So our MSB, that is 0, will be stored in B. Like this, if we want to slice the register, we can slice like this. Slicing means extracting a single bit. Or if we declare a register of 2 bits, reg 1 down to 0 B, that is B can store 2 bits. And if we want to slice the value from MSB followed by another bit, then we will assign B is equal to A of 3 down to 2. That is, MSB and followed by consecutive bit will be stored in B. So B value will be equal to 0, 0. So this is extraction of bits from the vectors. Like this we can extract. If we want to extract LSB, then we will declare B is equal to A of 0. Like this we can extract the bit. Or if we want to extract this bit, then we will write B is equal to A of 1. Like this we can extract the bits from where and which position from the vectors. So this is all about the data types, vectors, registers, wires in the Verilog. Hope you all understood these concepts, and if you have any doubts, you can ask me. I will try to clarify. So yeah, that's about today's session.